Hi folks, we're going to take a look at number 5A from the April 12th worksheet. Okay, so here it says that show that vector negative 110 can be written as a linear combination of these two vectors here. Okay, so let's remember that a linear combination allows us to multiply these vectors by a scalar and then add them up. Okay, so essentially what we need is we need to be able to write negative 110, this vector here. It's a linear combination, so I'll choose m and n to represent my my scalar multiples. Okay, so it has to somehow be written as some scalar multiple of negative 3, 6, okay, plus some scalar multiple of negative 4, 4. Now, based on what we talked about, since these two vectors are non-zero and non-collinear, this should be able to be done. These are what we call basis vectors for R2. Okay, so let's see how we can do that. So we just do some algebra. So here, not really much to do on the left-hand side of the equation, but here I could distribute that scalar multiple into the vector. So I can rewrite this as negative 3m and 6m. Okay, and here plus negative 4n and 4n. Okay, and then I can add these two vectors together, okay, by just adding individual components. So the x component is just going to be negative 3m minus 4m. So negative 3m minus 4n. And then the y component is going to be 6m plus 4n. Okay. And in order for these two vectors to be equal, the x component and the y component has to be the same. And this is where we see how this problem is going to be solved. It's just going to be a nice system of equations. So that means the x component, negative 1, has to be negative 3m minus 4n. Okay, and the y component, 10, has to be equal to 6m plus 4n. Okay, and this is actually quite nice because I already have the same coefficient in front of the n values. So here we can just add the two equations. So here we end up with 9 equals negative 3 plus 6 is 3m, and so m is equal to 3. And then here, let's stick that into the first equation. Negative 1 equals negative 3 times 3 minus 4n. So here we have 4n equals negative 9 plus 1. That's negative 8. So n is equal to negative 2. Okay, so that means if I take 3 times the first vector minus 2 times the second vector, I'll be able to generate this vector negative 110. Okay, and because these two vectors are non-collinear, they're non-parallel, I should be able to combine these two to get any vector on the Cartesian plane. Okay, that's it for this one.